Hi, my name is Christian, and I will be giving this tool demo for the paper titled Towards Probabilistic Session Type Monitoring. This is the repository in which the tool can be found in. You can follow the instructions found in the README file I've just shown, and now I can just clone, compile, check out the branch and compile the sources. Okay, now that the source is compiled, these are the connection managers in which the monitor will use to communicate with the interacting parties. And this is the type in which the monitor will be synthesized from, in which we have receive guess, receive help, or receive quit as specified in the paper, and the server will reply with either send correct or incorrect. We are now synthesizing the monitor by passing that file to a given function in which synthesizes the monitor. These two files are the files generated. This is the actual monitor, and we just have to copy this package statement up front. This up here is the meta information the monitor keeps on the observed behaviors, and this is the synthesize function for receiving from the client side, whereby it can receive either guess, help, or quit as stated in the type. Once it receives either of them, it increments the counters and then checks the intervals accordingly. If either of the stated probabilities within the type does not fit within the calculated confidence interval, then the monitor will issue a warning. If, for instance, the client sends guess, the monitor will continue accordingly to the type, whereby it will receive either correct or incorrect, but this time it will receive them from the server. Similarly, it will increment the counters and check the intervals and issues warnings if they're not being respected, as you're seeing here. It will then proceed according to the type once again, and this time it will recurse back to the previous function. These are the classes synthesized which represent the type in Scala according to the library L-channels. And now we can uncomment these lines found within the connection managers, in which they basically translate messages to and from TCP format and the classes representing the types within Scala. And now we have everything in place to start executing some experiments. I first start a Python server in which we parameterize it with the probability of sending correct 0.01, the probability of sending incorrect 0.99, and now we can start the synthesize monitor by passing the listening and the forwarding ports 1330 and 1335 together with the desired confidence level, which in this case we pass 4.4172, which represent a confidence level of 99.999%. If you see on the top left, we're also starting a client written in Python, which once initialized will send a series of messages based on the specified probabilities. In this case, we specified 0.75 for sending a message with the label guess, 0.2 for help, and 0.05 for quit. Now, as you shall see, once we execute this client, the monitor should not issue any warnings. And as expected, from what you can see down in the terminal containing the monitor, we had no warnings issued in this particular execution. We can now consider another experiment with the same parameters. We can start the same client with the same parameters once again, and also the same monitor with the same confidence level. And as expected, once again, the monitor does not issue any warnings. And this is because we assigned a high confidence level, and also because the client is indeed respecting the probabilities stated within the type. If we try something else, such as assigning the probability of sending guess to 0.2 and the probability of sending help 0.75, we will see the monitor does indeed issue these warnings of help and of guess, showing in each case where the specified probability has fallen outside of the calculated confidence interval. We can also see the case whereby rather than the client not respecting the specified probabilities, it is the server which disobeys the specified probabilities. In this case, we're going to start the server with probability of sending correct and incorrect equal, both of 0.5, and we'll start the same monitor synthesized earlier from the same session type. While the monitor starts, in the other terminal I will start another client, but this time respecting the specified probabilities. And as we shall see, the monitor will issue warnings for the server, since it is disrespecting the specified probabilities. And as expected, it issues warnings for both correct and incorrect, and in both cases specifying where the specified probabilities have fallen outside of the calculated confidence interval. Let's now consider a different example, and this time the session type states that the server will either receive heads or tails, each time with probability 0.5 of both heads and tails. This time the monitor will be started together on the same JVM with the server in a separate thread, and this time we also specify a confidence interval of 95% rather than 99.999% as in the previous examples. Now we started the monitor together with the server, and in the other terminal we will start a client in which we can control by typing in H or T on the keyboard. Okay, now we can start the client and we can type H for sending heads and T for sending tails. And as you saw, after sending 3 consecutive heads, the monitor issued a warning for both receiving heads and receiving tails. However, once we sent 1 tails, the monitor issues 2 info messages indicating that the specified probabilities have both fallen back within the calculated interval. However, if we keep on sending tails, the monitor will eventually issue another couple of warnings specifying that the specified probabilities have once again fallen outside of the calculated confidence interval. And similarly, if we send 1 more heads, it will topple back the specified probabilities within the calculated confidence intervals. As you see, once we send 2 more tails, the specified probabilities have fallen once again outside of the estimated confidence intervals. If we keep on sending more tails, you will see that this time it will take longer or much more messages of heads to topple back the specified probabilities within the estimated confidence interval. Thank you very much for watching, and I hope that the proposed tool-oriented methodology is now clearer.